Hi everyone, my name is Ramesh 21951 A04 F 0 of branch ECC section. In this presentation, I am going to talk about unitary matrix introduction. For matrices, the orthogonality over the real number field. See orthogonal matrix for the restriction of the allowed evolution of natural quantum systems that ensures the sum of probabilities of all possible outcomes of any event always equals 1. See unitary. In linear algebra, a complex square matrix U is unitary if its conjugate transpose, that is U star, is also its inverse, that is if U into U is equals to U into U star, that is equals to U into U inverse, that is 1, where that is sorry I, where I is the antimatrix. In physics, especially in quantum mechanics, the conjugate transpose is referred to as the Hermitian adjoint of a matrix, and it is denoted by a dagger, which is like a plus symbol. So the equation above is written, that is U dagger into U, that is U into U dagger, that is I. I is the antimatrix. The real analog of a unitary matrix is an orthogonal matrix. Unitary matrix have a significant importance in quantum mechanics because they have preserved norms and thus probability amplitudes. Properties for any unitary matrix U of a finite size, the following hold: due to complex vectors, that is suppose x and y multiplication by U preserves their inner product, that is ux comma uy, that is equals to x comma y. U is diagonalizable, that is U is unitarily similar to a diagonal matrix. As a consequence of the spectral theorem, thus U has a decomposition of the form, that is U is equals to VD V star, where V is unitary and D is diagonal and unitary. D is diagonal and unitary both. U is normal. U into U is equals to U star. U into U star, that is jet U is equals to 1. It eigenspaces are orthogonal. U can be written as U is equals to EIH, where E indicates the matrix exponential, I is the imaginary unit, and H is a Hermitian matrix. For any non-negative integer n, the set of all the n into n unitary matrices with matrix multiplication forms a group called the unitary group, that is U of n. Any square matrix unit with unit Euclidean norm is the average of two unitary matrices. Next, the equivalent conditions. U is unitary and U star is also unitary. U is invertible with U inverse, that is U inverse is U star. Um, the columns of U form a orthogonal basis of C into n, that is C power n, with respect to the usual inner product. That in other words, U into U star is equals to I. U is isometry with respect to the usual norm, that is Ux of 2 is equals to x, of 2 for all x belongs to C power n, where x of 2 is equals to under square root of sigma to the base I to the power n is equals to 1 xi mod xi whole square. This is the formula. Is a normal matrix. Equivalently, there is an orthogonal basis formed by eigenvectors of u with eigenvalues lying on the unit circle. Elementary constructions: 2 into 2 unitary matrix. The general expression of a 2 into 2 matrix is this is a 2 by 2 matrix, that is 2 by 2 unitary matrix, that is u is equals to a comma a b minus c to the power I psi into b star e to the power of I psi into a star, that is mod a square plus mod b square, which depends on four real parameters: the phase of A, the phase of B, the relative magnitude between A and B, and the angle phi. The determinant of such a matrix is det of U is e power I into phi, and the subgroup of those elements U with det of U is equals to 1 is called the special unitary group SU of 2, that is denoted by SU of 2. The matrix U can also be written in this alternative form. This is U is equals to E in e power I phi by 2, that is E into e power I phi 1 cos theta, e power I phi 2 cos sin theta, minus e power minus I phi 2 sin theta, e power minus I phi 1 cos theta, which is introducing phi 1 is equals to psi plus delta, and phi 2 is equals to psi minus delta, takes the following factorization, that is u is equals to e power I into phi by 2, that is e power I phi 0 0 e power minus I phi into cos theta sin theta minus sin theta cos theta into e power I delta 0 0 e power minus I delta. The expression highlights the relation between 2 by 2 unitary matrix and 2 by 2 orthogonal matrix of angle theta. Another factorization is u is equals to cos alpha minus sin alpha cos alpha e power minus e0 e power minus I cos beta sin beta minus sin beta cos beta. Many other factorizations of a unitary matrix in basic matrix are possible. Thank you.